Okay, so welcome back. Now, in this video, we're going to talk about component vectors. Meaning, what if we have a vector, in a lot of cases, physics and other cases where we want to split up into a vector into its component vectors. For example, you throw a ball or something's launched into the air, and we're interested in what the vertical component and the horizontal component of the force is. So if the rock is launched or the rocket is launched at an angle, right, from the ground, then we want to, in a lot of cases, know what the horizontal, what the horizontal force is, or the horizontal velocity, and what the vertical velocity or force is that's going on. And so a lot of cases we want to split up a vector into its component vectors. And so every vector will have a horizontal and a vertical vector, or most of them will. Okay, so for example, in this case here, we have the vector, let's call this vector V, and this is 2, 3. Okay, now we can split this up into its component vectors like so, because again, we know that the horizontal is going to be what? It's going to be add up to the 2, right? So we can add this here to the 2. Okay, so this is going to represent, let's say, V1. Okay, and this would be this is going to be what? It's going to be 2, 0. Right? So that's going to be its position vector. And then the other one is going to be in the horizontal, or excuse me, the vertical direction, and that's going to be 3 units up, right? So this would be like V2. Okay? And so this is going to be what? 0, 3. And notice that when you do add these vectors, right, if you slide this vector over, they do add, right, you get a right triangle, they do add to the resultant vector. Okay? And so we can also verify, so we know, right, the magnitude of these two vectors. So again, remember, we can find the resultant, right? The resultant vector, we know how to find the magnitude of the resultant vector, right? But we also know how to find the magnitude of the resultant vector of the component vector. So let's look at that for a moment, just so you can see the connection between the two. Okay, so here we have what? The V1. So V1, the magnitude of V1 is equal to what? It's going to be the square root of 2 squared plus 0 squared, right? Which is going to equal the square root of 4, which is 2. And then for V2, the magnitude of V2 is going to be the square root of 0 squared plus 3 squared, which is going to equal 3. Okay? Now, what about the magnitude of V? Well, the magnitude of V can be written as in reference or in relationship to the magnitudes of the component vectors. Okay, by using the Pythagorean identity. Because we can say, hey, this length here squared, this magnitude squared, plus this magnitude squared will equal this magnitude squared. So if I use this magnitude, I can write this magnitude using the Pythagorean identity as the square root of the magnitude of V1 squared plus the magnitude of V2 quantities squared. And look what we get. We get the square root of what? 2 squared plus 3 squared, which is exactly what we get when we find the magnitude of this one. It's 2 squared plus 3 squared, the square root of, and that's what we got. And so we get the exact same answer which we should, right? Because of the Pythagorean identity, because we're adding component vectors that are perpendicular to each other, right? We've got a horizontal and we've got a vertical. So it should make perfect sense that this would work. And so we get the square root of 4 plus 9, which gives us the square root of 13. Okay? And so now we have a way of finding the magnitude of a vector by using the Pythagorean identity and its component vectors. Okay, so now, the angle, right? So the angle, so what if I want to find the direction, right? So I want to find this angle theta. Well, remember, theta is y over x, right? Tangent theta, I should say. So tangent theta is y over x, but in this case here, it's going to be the magnitude of y, right? So that's going to be equal to well, y is just what? In this case, v2. Right? So this is just going to be the magnitude of v2 over the magnitude of v1, which again just gives us 3 over 2. And so if we take the inverse tangent of both sides, what do we get? We get theta equals tangent inverse of 3/2, which then gives us approximately, put that in your calculator, of course just make sure you have degrees, 56.3 degrees. And that's it. So we'll come back, we'll do an example. Have a great day.